Hello everyone. In this video, I am going to explain implementation of queue using arrays. In previous video, I explained what is queue and operations we can perform in queue also. Now we'll see how to implement with the help of arrays. We can implement queue concept using arrays and linked list also. This video I am going to implement with the help of arrays. Okay. So first I am going to declare one array. What is queue? First of all, it is a linear data structure which follows first in, first out. It means the element which is inserted first, that one only we can delete first. Okay, first I am going to declare one queue, means one array, because I am going to implement with arrays. Now, we'll take one maximum value. Now, the maximum value I am going to take 5. So, for 5 elements, it allocates the memory and always index starts with 0. Okay, this is one array. Now I'm going to take the array name is q. Okay, this is q of 0, q of 1. With the help of index, we can access the memory locations. Fine. Now, what are the operations we can perform in queue? We can insert the elements, we can remove the elements. Insert is nothing but enqueue. So there are two endpoints in queue. One is rear and another one is front. This is rear and this is front. Okay, from rear side we have to insert the element. Initially front is -1 and rear is also -1. Instead of writing completely front and rear, F means front, I have written FR. F means front, R means rear. Initially both are -1. Okay, rear side we have to insert the elements. Okay, first insert the element means in which position we have to insert 0, means rear side. Initially it is -1. Now increment rear value by 1. In that location we have to insert. Okay, I am going to increment rear and inserting element. Now rear becomes 0. Now what is front? -1. But there is one element in queue. After inserting one element, now if there is only one element, means this becomes front element and this becomes the last element. This is only the front and this is only the last element. Okay. So now if front is -1, if at all if we insert one element, F also becomes a 0 because there is one element. Now F and R becomes 0. Next, again insert. Means rear side we have to insert the element. Increment rear value. Means 0 plus 1, 1. Now rear becomes 1. In this location, insert the element. Now no need to change front. This is front. First inserted element. So every time no need to change the front. Whenever we insert first element, front and rear becomes 0. Every time only rear only we have to increment. See, again insert means increment rear value by 1, insert the element. Again insert, increment rear, insert the element. Again insert or enqueue means increment rear value and insert the element. Again enqueue. So enqueue means we have to insert in fifth location, but there is no fifth location. So I cannot insert the element because queue is full. So I have to write the condition. See, whenever we see the diagram, easily we can say queue is full. But for compiler, can't see the diagram and it cannot give you a message queue is full. So we have to give one condition to the compiler. What condition we have to give? See, here rear is 4. That is the reason we are saying queue is full. So what is maximum value? 5. So if maximum is 5, always the last index is 4. In last index means rear. So if at all rear is 4, then queue is full. So rear is 4 means maximum -1. If rear equals to maximum -1, it means queue is full. Otherwise, we can insert the element. Where we have to insert the element? Always rear side we have to insert the element. Okay, now I'm going to write enqueue function. So first, whenever we are inserting the element, we have to check it is full or not. If we take this example, it is full, I cannot insert the element. So we'll write the condition. If rear equals to maximum -1, then print one message, queue is full. We cannot insert the element. Else, so otherwise we can insert the element. We'll take one more queue. Okay. Name of this array is Q only. This is name of the array is Q. Index starts with 0. Okay. Fine. Now, rare is initially what is front? Minus 1. Rare is also minus 1. Now, rare is maximum minus 1? No, it is minus 1. So, we can insert the element. So, first of all, we have to read one element. Printf, enter any element. So, that element you can assign it to any one variable. I'm going to assign to x. Now where we have to insert this x in 0th location. Means always you have to increment rare value by 1. In that location we have to insert the element. Okay, after incrementing rare, so minus 1 plus 1, rare becomes 0. In this location you can insert the element. If at all front is minus 1, then front is also assigned to 0. If front equals to minus 1. Then front is assigned to 0. This is simple if. If at all it is minus 1, assign to 0. Otherwise, no need to assign. Okay. Next, always we have to increment rare value by 1. Rare equals to rare plus 1. In that location, we have to assign the value. Very simple. We'll see once again. So, initially, we'll take one empty array again, so easily you can understand. See, first time whenever you call enqueue function, initially front is minus 1 and rare is also minus 1. Now rare is maximum minus 1. No, it comes to else part. Enter any one element that will be assigned to x. So I'm going to assign some 50. Okay, now x becomes 50. Now front is minus 1. Yes, front is minus 1. So front is assigned to 0. Okay, fine. Now rare also increment by 1. Now rare is minus 1. Minus 1 plus 1 it is 0. In this rare location, assign x, q of rare. Q is array name, rare means 0, q of 0 will assign 50. Fine. Okay, next step. Again, whenever you call enqueue function, again it will check the condition. Now rare is maximum minus 1. No, it is 0, not maximum minus 1. So it is not full. So it comes to else part. Again, read one element that will be assigned to x. Now I am going to assign 60. Now x value is 60. Now again, once again it will check the condition. Front is minus 1. No, it is 0. So it won't change the front value. Always it will change only first time. When minus 1, then only it will be assigned to 0. Otherwise it won't change the front. Always it increments rare value by 1. Okay, now rare is 0. So increment rare value by 1 and q of rare equals to x. 60 will be assigned to x. See, like this, we can insert 5 elements. Again, insert means increment rare and insert the element. Okay, so like this, we can insert the elements into q. This is enqueue operation. Next, we'll see dequeue function. Dequeue means delete an element from queue. So, if these are the elements which are present in queue, now front is 0 and rare is 4. So, now the queue is full. So, if it is full, not a problem, you can remove the element. If it is full, we cannot insert, but we can remove the element. Okay, now dequeue means which element we have to remove first? Always first inserted one only. Front element we have to remove first. So, how to access this 50? Array name is q. This index is assigned to f. So always we have to remove q of front element. F means front. Instead of writing complete front, I have assigned to f. So q of f. So this front element will remove first. Okay, I am going to remove this 50. After removing this one, which one becomes front element among all these 4? Which one we have inserted first? 60. So once we remove this one, the next one becomes the front element. So what you have to do? Increment front by 1. Increment front value by 1. Now front element is 60. What is front? 1. Front is 1. Front element is 60. Again remove means q of f. That is 60 we have to remove and front is incremented by 1. See, again remove. So remove this element and front is incremented by 1. Again remove. Remove this element and front is incremented by 1. Now f equals to r. It means there is one element in your queue. So now again remove. yes, one element is there, we can remove. Again, Q of F we have to remove and front is incremented by 1. Now again remove means it is not possible because the Q is empty. Okay. So how can we write the condition? How to check the condition means front is greater than R. So one condition is if front is greater than R, it is empty. Another one it is if front equals to -1 and rear equals to -1, or else you can check if front is -1 means it is empty. So these two conditions we have to write. Front greater than R means it is empty. Front is -1. There is no front element means the Q is empty. If any one condition is true, the Q becomes empty. So we'll take one more example. See again, this is front and rear is 2. So delete or DQ means Q of front element and increment front value by 1. Again, Q of front, increment front. Q of front, increment front value by 1. Now it is empty. Front is greater than rear. So front is greater than rear or front is -1, then it means the Q is empty. So first in DQ function, I am going to write empty condition if front is greater than rear or front equals to -1. It means Q is empty. You cannot remove the element. Otherwise, simply we can remove the element. Which element we have to remove? Printf deleted element equals to percentile D Q of F. Q of F element we have to remove. So after removing, the next one becomes the front. So front is incremented by 1. So this is DQ function. Next function it is display. In display also, if at all Q is empty, we cannot display the elements. Otherwise, we can display the element. That empty condition, you can write it here. Otherwise, if it is not empty, we can display the elements. See, what we have to display, this is Q array, this is Q. We have to display elements from Q, 50, 60 and 70. It means Q of 0, Q of 1, Q of 2. So we have to repeat one for loop. So first I'm going to write if front is greater than rear or front is -1, print one message that is Q is empty. If at all it is empty, we cannot display the elements else. So display Q of 0, Q of 1, Q of 2. So we have to repeat one for loop. For I starts from always it is 0. No. See, if we take this example, elements is, there is no element in 0th location because this one is removed. So once you remove this one, F becomes 1. So we cannot start with 0. Always we'll start with front one only. Front element to rear element. We have to repeat for loop. I starts from F. I less than or equals to R, I plus plus. Printf percentile T Q of I. So this is display function declaring this I. This is display function. I'm going to write main function also. So first initially front and rear are -1. So I'm going to declare it as global int front equals to -1, rear equals to -1 and declare the array Q of max. Max also we have to declare hash define max 5. I'm taking the maximum value is 5. You can take any number. And next main function. In main function, first I'm going to display one menu. Printf 1 means NQ. You have to call NQ function in that will insert the element 1. Next one it is DQ. If at all you want to remove, just simply call DQ function. Then display function. And you don't want to perform the operations, then you can simply call exit function. So printf, select your option, enter your option. You can select any one option. So 1, 2 or 3 or 4. So all these are integers. So that choice I'm going to assign to ampersand ch. Okay. Now If at all CH is 1, call NQ. Otherwise, if at all it is 2, DQ. Else, if CH is 3, call display. Else, if CH is 4, exit. So, else if ladder you can write, or else simply we can write switch case, switch of CH. So, if at all it is 1, then call NQ function, break. Case 2, call DQ function, break. And case 3, call display function and break. Last one, case 4, it is exit. Exit means simply it will exit from the program. Now I'm going to close this switch case. See, first time when we execute this main function, it will display one menu. It will ask you one choice or option. So if at all, if I select one, simply it will call NQ function. It will execute NQ function. So one element we can insert in this way. Again, you want to perform any one operation. Again, we have to come back and we have to execute same statements. So repeatedly, whenever you want to execute the statements, all the statements will write in one loop. So I am going to write all these statements in while loop. While of 1 means always the condition is true. 1 means true condition. So first time when we execute, condition is true. It display the menu and you can select the option based on the your choice. It will call particular function. And again, it will come back to here. Again, it will ask you and once again it will ask you your choice. So again, you can select DQ or display. Like this, repeatedly you can select. If you don't want to continue with operations, simply you can call 4. Select 4. If CH is 4, simply it will call exit function. This is complete program. So first always starts with main. Here I did not declare some few. If I miss any local variables, later you can declare. This is int CH. Okay, execution starts with main. Always the condition is true. It will display the menu. You can select the choice. If choice is 1, simply it will call NQ function. This is NQ function. Already I explained clearly. If it is not full, then read one element and it will insert into your queue. Again, it will come back to same calling statement. Break means exit from switch and again go back to while loop. Again, it is true. Again, it will display the menu. Next time, I want to remove the element. Then I have to select 2. If it is 2, simply call DQ function. It will remove the front inserted one. DQ function. So simply it will remove the front element. Again it will come back. So repeatedly it will ask you your choice. So you don't want to continue with this, simply select choice 4. So when you select exit, simply it will exit from your program. This is Q program. Any doubts you can ask in comment section. Thanks for watching.